I've seen teams spend 6 months arguing about REST versus GraphQL. 6 months of architecture meetings, Confluence docs, proof of concept branches, heated Slack threads, engineers with strong opinions pulling in opposite directions, product managers wondering why the API wasn't done yet. Here's the truth: you're probably overthinking it. The REST versus GraphQL versus gRPC debate is one of those engineering conversations where the loudest voices often have the least experience with what actually happens when these APIs hit real production traffic. Each approach has a genuine sweet spot. Each approach has genuine weaknesses. The decision matrix is actually not that complicated once you cut through the religious wars. Today, I'm going to give you the clear-eyed version. What each of these API styles is actually good for, where each one struggles, how you decide, and why just pick REST is correct advice in a surprising number of situations where engineers are tempted to reach for something more sophisticated. I'm Alex, and this is Bot Thoughts by AmtocSoft. Let me start with REST because REST gets unfairly maligned in tech circles where everyone wants to seem like they're using cutting-edge technology. REST, representational state transfer, is not technically a protocol. It's an architectural style. You have resources. Resources have URLs. You interact with them using HTTP methods. Get to read, post to create, PUT or patch to update, delete to remove. Responses are typically JSON, stateless, cacheable, simple. REST has won the internet. Virtually every public API you've ever used is REST. Stripe, Twilio, GitHub, Shopify, Oz, SendGrid. These are some of the most successful and heavily used APIs ever built, and they're all REST. Why? Because REST's design constraints are also its strengths. URLs are human-readable and self-documenting. You see /API/v2/users/123/orders, and you know what it does. You can curl it directly from your terminal. You can test it with Postman in 30 seconds. You don't need a special client library. You don't need schema files. You don't need build tooling. HTTP's caching model maps cleanly to REST. GET requests can be cached by browsers, CDNs, and proxies automatically. This is not a minor point. It's a massive scalability advantage for read-heavy APIs. Error handling is standardized. HTTP status codes exist for a reason. 200 means success. 400 means bad request. 401 means unauthorized. 404 means not found. 429 means rate limited. 500 means server error. Every REST client in every language already knows how to handle these. REST is also versioning friendly. You want to change an API in a breaking way? Add v2 to the path. Old clients keep using v1. New clients use v2. You can run them in parallel forever. This is clunky, but it works, and it works at massive scale. The cases where REST struggles: when you have clients with widely varying data needs, a mobile app that needs minimal data to be fast on slow connections, and a desktop app that needs rich nested data. With REST, you either underfetch. The mobile app has to make multiple requests to get what it needs, or you overfetch. The mobile app receives a huge payload and throws most of it away. That's the core problem REST solves poorly. GraphQL was open-sourced by Facebook in 2015, and it was born out of a very specific problem. Facebook's mobile app in 2012 was making hundreds of REST API calls per screen, and the network was killing performance. The insight behind GraphQL is elegant. Instead of the server deciding what data to return, the client declares exactly what data it needs. In a single request, your client sends a query. The query looks a bit like JSON. It specifies exactly which fields you want, from which types, with optional arguments for filtering and pagination. The server returns exactly that shape, no more, no less. This solves the overfetching and underfetching problems perfectly. Your mobile app says it needs the user's name, avatar URL, and unread message count. That's all it gets, not the entire user object with 30 fields, just those 3. Your desktop app needs the full user profile plus their recent orders with line items. It asks for all of that in one query. The server handles both. The benefits compound in complex domains. When you have highly interconnected data, think social networks. E-commerce with products, variants, inventory, reviews, sellers, GraphQL's graph traversal model maps naturally to the domain. Clients can navigate relationships in a single query that would require a waterfall of REST calls. Type safety is a first-class feature. Your GraphQL schema defines every type, every field, every relationship, every argument. Code generators can turn that schema into TypeScript types automatically. Your entire client-server contract is enforced at the type level. That's genuinely powerful for teams building complex frontends, but GraphQL has real costs. Complexity is the first one. GraphQL is a system, not just a protocol. You need a schema. You need resolvers for every field. You need a runtime, Apollo server, Yoga, Hasura, whatever. You need to solve caching, which is harder than with REST because post requests can't be cached by HTTP infrastructure by default, and persisted queries are the typical workaround. You need to think about N+1 queries. A single GraphQL query can accidentally trigger hundreds of database queries if your resolvers aren't written carefully. Data loader is the standard solution, but it adds complexity. File uploads in GraphQL are also awkward. The spec doesn't natively support multi-part uploads. Most teams end up with a REST endpoint for file uploads alongside their GraphQL API. And for simple APIs, GraphQL is dramatically over-engineered. If you're exposing CRUD operations on a few resource types to external developers, REST is simpler to document, simpler to test, and simpler to consume. gRPC is Google's open-source RPC framework, and it is categorically different from REST and GraphQL in its design goals. REST and GraphQL are designed for human-readable communication. JSON is text. You can read it, you can curl it, you can debug it in your browser. gRPC is designed for machine speed. It uses protocol buffers of protobuf as its serialization format. Protobuf is a binary format. It is compact, fast to serialize, and fast to deserialize. It is not human-readable. You define your service in a proto file. The proto file defines messages and RPC methods. You run the proto compiler, and it generates client and server code in your target language. The generated code handles all the serialization, connection management, and error handling. You just call functions. The performance differences over REST are significant. gRPC with protobuf typically uses 3 to 10 times less bandwidth than equivalent REST with JSON. Serialization is much faster. The transport layer is HTTP2, which gives you connection multiplexing, header compression, and bidirectional streaming. For internal microservice communication, where you're making millions of calls per day, these differences compound into meaningful cost and latency savings. gRPC also supports streaming natively. Server streaming, the server sends a stream of responses. Client streaming, the client sends a stream of requests. Bidirectional streaming, both sides stream simultaneously. This maps naturally to use cases like real-time data feeds, file uploads, and live dashboards. The downside is the friction of binary protocols. You cannot curl a gRPC endpoint and read the response. You cannot test it in Postman without a plugin. You cannot inspect traffic easily without special tooling like grpcurl or gRPC gateway. Debugging is harder. Browser clients need a gRPC web layer, which adds complexity. The sweet spot for gRPC is internal microservice-to-microservice communication. Services that need to be fast. Services where you control both client and server and don't need to worry about external developer experience. Services where the strong typing of protobuf schemas is a feature, not overhead. Okay, here's the decision matrix. Simple and direct. Use REST when you're building a public API consumed by external developers. You want maximum interoperability and ecosystem support. Your API is CRUD-heavy with a small number of resource types. You want HTTP caching to work naturally. You're a small team and want to minimize tooling complexity. In doubt, start with REST. It's the right default for the vast majority of APIs. Use GraphQL when you have multiple client types, mobile, desktop, third-party, with significantly different data needs. You have highly relational data with complex nested queries. You're building a product API that powers your own front end, and the front end team needs flexibility. You're comfortable with the complexity trade-offs, and you have the backend resources to implement it well. GraphQL adds real value for complex consumer-facing products. It adds overhead for everything else. Use gRPC when you're building internal service-to-service communication. Performance and efficiency are critical. You need streaming. Your team is comfortable with protobuf. You control both client and server. If you're building a new microservices backend and you're only communicating internally, gRPC is genuinely the best choice for most of those service boundaries. Here's the part nobody talks about. You don't have to pick one. Many sophisticated production systems use all three in different layers. Public API, REST, clean URLs, easy documentation, maximum interoperability. This is what external developers consume. Internal microservices, gRPC, fast binary protocol, strong types, streaming support. This is how your services talk to each other. Front-end to back-end for front-end, GraphQL. Your mobile app and web app have a GraphQL API designed specifically for their needs, with a BFF, backend for frontend, layer translating GraphQL queries into gRPC calls to downstream services. This is not an exotic architecture. This is how Shopify works, how Netflix works, how many large-scale product companies structure their API layers. The trap to avoid is premature sophistication. Don't reach for GraphQL on day one because you might eventually need it. Don't add gRPC before you have microservices that need to talk to each other. REST can scale further than most teams will ever need. Start simple. Add complexity only when a specific, concrete problem justifies it. The engineers who spend 6 months arguing about REST versus GraphQL are usually solving a problem they don't have yet. Ship the REST API. Build the product. Learn what your actual data access patterns look like. Then make an informed decision. REST, GraphQL, gRPC, they're not in competition. They're tools with different purposes. REST is for public APIs and simplicity. GraphQL is for complex clients with diverse data needs. gRPC is for high-performance internal services. The right answer for most teams, most of the time, is start with REST. Add GraphQL when your client diversity problem is real and painful. Consider gRPC for internal service communication when you have the operational maturity to support it. Don't let architectural debates become 6-month blockers. Pick the simplest thing that could work. Build something, ship it. Full comparison post with benchmarks, code examples in Node.js, and a concrete decision guide is on the blog, link in the show notes. I'm Alex. This is Bot Thoughts by AmtocSoft. Subscribe wherever you listen to podcasts, and I'll see you in the next episode.